Now we're going to work homework problems 28 through 33. Looking at 28, it's asking which of the force diagrams show an object moving to the right at constant speed. So why don't we just analyze what's happening in each one of these? Let's look at A. For A, F net in x equals, let's look at what's actually happened. I've got 20 going to the right, and then I have 20 going to the left. So this is 0. So for A, my acceleration is 0, so I'm either moving at a constant velocity or it's not moving. One of the two. Let's look at B. Alright, for B, sum of the forces in x equals, let's see, I have 20 going to the right, minus 15 going to the left, so this is 5 newtons to the right. So B is accelerating to the right. C has no motion at all in the y direction, in the x direction. And the forces in the y direction are balanced. I've got 25 going up and 25 going down. So the sum of the forces in y, we don't have to do y, but that's okay. 25 minus 25 are 0. So the acceleration in both x and y for the C are also 0. Now let's look at D. Summation of forces in x. Let's see what we've got. I only have one force. That's 20 newtons to the right. So this one is also accelerating to the right. So I guess to answer the question, which one's moving at a constant speed? The only one moving at a constant speed is possibly A, because there are no forces moving. I guess there could be. This one could be moving to the right. This could be an ice skater skating on ice, encountering no friction. She's already got a velocity, so she could be moving constant velocity to the right. Now let's analyze this graph. I have velocity and I have time. Now, whenever velocity is a constant, so that's this line right here, whenever it's horizontal, that tells me I have constant velocity. Whenever velocity is changing, okay, this is going to be a positive acceleration, and then these are going to be the negative accelerations. These are sloping down. So all I've done right now, so A is negative for C. Let's see. A is 0 for F. All I'm doing right now is analyzing the graph itself, and then we'll go down and we'll look at the problems. And here A is positive, and here A is positive. So let's now go look at the problems. During which time interval are there no forces? So now we're looking for when the forces are balanced. So we're looking for A equals 0. Which three areas did we have A equals 0? That's B, D, and F. I wrote over it because the velocity is a constant in those three regions. And it acts for which time interval. So we could come down and find the actual times if we wanted to. During which time intervals are the forces balanced? Once again, balanced forces means acceleration is 0. Balanced forces means acceleration 0. So this is once again B, D, and F. During which time intervals is there a net force acting upon the object? When there's a net force, there's going to be an acceleration of some sort. So we're accelerating A, C, E, and G. Okay? Because the velocity is changing, therefore when there's a change in velocity, there is an acceleration. Okay, during which time intervals is the force acting to the right? Okay, to the right means we're going to be looking for positive accelerations. Which intervals have positive acceleration? That's A, and E. And the last one, during which time intervals, if any, is the force acting to the left? Well, a left force means negative acceleration. And which regions do we have a negative acceleration? That's C and G.